The renin-angiotensin-aldosterone system starts at your kidneys. In your kidneys, there are structures that we call our juxtaglomerular apparatus, which contain baroreceptors. Our baroreceptors, they will note changes in pressure. Okay. Our renin-angiotensin-aldosterone will start if the kidneys, specifically the baroreceptors in the juxtaglomerular apparatus, will detect a decrease in blood pressure. If there is a decrease in blood pressure, it will cause the release or secretion of our renin. Renin will then bind to a free-floating substance called angiotensinogen to create what we now call our angiotensin 1. Now, your angiotensin 1 is what we call an inactive substance. Inactive. So it needs to be converted to its active form. Luckily, the lung capillaries will create what we call our angiotensin converting enzyme, or what we call our ACE. It will then bind to your angiotensin 1 and create angiotensin 2. Now, your angiotensin 2 has two main effects. Number one, it is a potent vasoconstrictor. So it will vasoconstrict your peripheral blood vessels. Aside from that, it will also stimulate your adrenal cortex to release aldosterone. Your aldosterone, it will have two effects. The first one is that it will retain H2O. And the next one is that it will retain sodium, specifically through a process in our kidneys that we call reabsorption. So it looks like this. Your aldosterone class, it will target your distal convoluted tubules and your collecting ducts. Okay, it will cause them to increase H2O and sodium reabsorption. It will look like this. Okay. Let's say, for example, this is your distal convoluted tubule. This one, your DCT. And this one, running parallel to it, is your peritubular capillaries. This is where blood is. Okay? Your distal convoluted tubule, once it is triggered by our aldosterone, or stimulated by our aldosterone, it will now increase H2O and sodium reabsorption. Now, if you remember, reabsorption is taking back useful substances and sending them to your bloodstream. So, for example, this is your H2O and this is your sodium. They will be sent from your distal convoluted tubule back to your bloodstream. Now, if you send sodium to your proximal convoluted tubule or back to your bloodstream, water will also follow it. So therefore, there is an increase in the volume of H2O in blood. If there is an increase in H2O in blood, there will also be an increase in blood volume. There, blood volume. And if there is an increase in blood volume, it is expected that there is also going to be an increase in blood pressure. Okay? So we started from the low blood pressure. Okay? It triggered the start of our RAAS, and it ended with an increase in blood pressure back to normal. So in reality, class, this is just a compensatory mechanism. Okay, mechanism, because it compensated for the decrease in blood pressure, the initial decrease in blood pressure, by increasing the blood pressure through your renin-angiotensin-aldosterone system.